Hello and welcome to this very simple explanation of a weird quirk in launching rockets into outer space. Why is it done near the equator when and where possible? You might wonder, why is it that NASA is always launching their rockets from Cape Canaveral? Why not put the launch sites up on a mountain or out in the middle of a desert where if anything goes wrong, no one will be hurt? The reason this is not done and why launch sites are located near the equator where and when possible are all related to the same things. First, why not alternative sites such as deserts and mountain peaks? The obvious problems are firstly obvious. Access. Getting to a mountain peak is hard when just driving. Now try hauling massive rockets up there, and no truck is making that trek. Could you build tunnels, widen roads, flatten hills, etc.? Yes, but why do that when more realistic and reasonable options exist? And next is launch conditions. The top of a hill is going to experience more issues with wind, air conditions such as humidity, oxygen content, pressure, and so on, than a relatively sea level and stable launch site. All this makes it far more complicated to launch, even if you do gain a few thousand meters of extra height, and that is really all you are gaining, remember? A couple of kilometers up and that's about all there is to it for most possible locations it can be used. The trade is just not worth the trouble. Especially if something goes wrong and now you have rockets, astronaut parts or astronaut charcoal, and possible hazards spread out over a mountain range, which makes rescue or recovery impossible for both ethical reasons, but also for pragmatic forensic analyses of what went wrong with the launch. So now you can't recover the astronauts you should be recovering, and you can't figure out what went wrong there. What about a desert then? A desert is arguably somewhat better. You still will have a nightmare of a time getting the rocket to side, but you do at least somewhat do away with the issue of recovery when things go wrong. It is still a nightmare, well, nightmarishly hard at least, but theoretically possible. So why places like Cape Canaveral? Simply put, it was already set up in many ways. And not just the infrastructure for rocket launches, that was already there, but that was a separate issue. And no, we mean other key things like facilities and installations to track the launch. Just getting a rocket to go up, or at least somewhat up, isn't enough. You need to be able to follow it and know what is happening. These facilities are another key reason why both the desert and mountains are a terrible idea. If you have ever built a sandcastle, you will understand not just how hard it is to build on sand, but also how hard it can be to get there. Now imagine that, about 20, 30 or more radar and tracking facilities all needing support and infrastructure, staff, and more spread out over tens if not hundreds of kilometers. It's even harder on mountains, or worse yet, mountain ridges. The modest gain of up to, this is the extreme example, 4 kilometers, compared with the hundreds of kilometers in altitude that will be needed from the rocket launch, is just not a great trade-off. You're really not getting anything in the grand scheme of things for all that extra work, all that extra effort, and the minimal savings you will make in possible fuel you'll need for just a tiny amount of extra height at the initial launch. So now we have why most launches are near the equator, and they'll range from about 5 degrees off from the exact equator, somewhere up to, depending on where we're looking at, possibly up to 60 degrees. The launches we'll be comparing for the purposes of this video will range basically from 5 degrees off up to 28 degrees, so we'll focus on those to start with, but understand there are outliers to that particular comparison. The first consideration is purely logistical. Most launches, at least with regards to the USA, are from somewhere that has decent, if not great, support in the form of rail and land connections. It's just not practical to load your precious cargo worth billions of dollars onto a boat, hope it gets to where it's going, and we mean this not just for the rockets though, there's also the actual payload to consider, such as multi-million-dollar satellites. So being able to get them somewhere safe with a decent chance of them getting there without being lost in the depths of the ocean is pretty damn good. And of course, the cost savings you'll get from the equatorial launches are relatively minor compared to the loss if you lose the entire payload. This is not to say that not all countries do not rely on such a method. France and the European Space Agency are a particular example that you'll understand soon. Next we have what is the actual benefit from getting closer to the equator, and it's really quite simple. If you launch almost due east from the equator, you're taking advantage of the Earth's maximum rotational velocity. That's somewhere around 450 to 460 meters per second, and this will help you achieve orbital speeds at a somewhat lower threshold. Typically speaking, and understand this is a rough calculation, you'll be able to bring your speed that you need down to about 328 meters a second, rather than that previously mentioned 460. And that's purely those gains to be made in terms of the ability of the Earth to spin and basically catch the satellite, or in this case rocket, as it launches. Typically speaking, you're going to need somewhere closer to 7.8 kilometers a second for that to happen, or at least to stay in orbit. And once you account for things like wind drag, other variables and so on, you're getting closer to 10 kilometers a second. And that's what the satellite needs to stay up in space. So we have a big difference between getting to space in the first place and staying in space once it's there. This is where being closer to the equator becomes more useful. Strictly speaking, the closer to the equator you are, the lower the ground speed you need. Essentially, the closer to the equator, the faster you move, thereby lowering the speed required. Now, this has an effect on things like propellants. But for all intents and purposes, the faster you can go without needing more propellant, the more crap you can put into space. This, of course, also lowers the cost of putting things up there to start with. After all, fuel is expensive, and so are rockets. Strictly speaking, the lower you can reduce that cost, the more accessible it becomes. But low Earth orbit, or essentially most satellites, are going to have most of their cost made up from that particular charge. So why settle for somewhere like Cape Canaveral and not a territory or other location, at least in the case of the USA? Again, we look at logistics, but also pragmatism. Yes, you can gain something like 150 to 200 kilograms more payload capacity per launch by moving NASA to a closer latitude to the equator. Roughly speaking, every degree closer you get to something like the French example, you'll gain somewhere between 1.5 to 2 kilograms of extra payload. Now, this number does vary somewhat based on your comparison. For example, we are comparing French Guiana to Cape Canaveral, but if you instead compare French Guiana to the Russian Baikonur launches, you get a much greater reduction, and that's simply because the sheer capacity of Baikonur, because it's so far north by comparison, is much smaller. In fact, you get about a 60% reduction, for the Russian side at least, and this means it goes from roughly 3,200 kilograms per launch to 2,000 kilograms of payload capacity per launch, and that's because it shifts so much further and so much closer to the equator in the case of the French site in Guyana. This is not to say there are no reasons not to consider moving locations. Just remember, there is more latitude than just being as close as possible. For example, if you are within plus or minus 15 degrees of the equator, you basically don't have as much to worry about. You'll gain small improvements, but they are relatively minor comparative to the effort of setting up somewhere completely new, just to move a few degrees south or north. You get more from launching directly east than you do from this. After all of that, we should point out, rather importantly, that any choice relying purely on its location will need to bear in mind the very first issues we mentioned, the idea of catastrophic failure. Where will a rocket crash and how? Will it be over inhabited land, or better yet, can it happen over the open ocean where even the precious cargo could be lost, but at least there'll be no surprise NASA exhibitions inside someone's house, or worse yet, a whole town? This has happened multiple times in China because China launches over mainland China when sending things into space, and unfortunately, their various rocket parts crash back down to Earth. If, and this is important to note, if the payload is heading for a polar, retrograde, or sun-synchronous orbit, then it can actually be more useful to shift further north or south, that is towards the Earth's poles. And this is because you need to cancel out the escape velocity. Basically, you don't want the thing going so far into space that you no longer have it rotating around Earth near the poles. The extra speed imparted from launching near the equator is actually detrimental in that case, and so you can ultimately get more from launching further north or south. And, of course, you need to compare this against what you're trying to achieve, because obviously launching from where you don't want to be launching from will not be helpful at all. It's a balancing act between the cost of launching, the location for which you're trying to launch, the type of launch you're trying to achieve, and how much you're willing to pay. So yes, closer to the equator is better, but not a perfect answer. There are realistic and practical issues when it comes to launching anything into space. Where it is, the logistics of getting it there, the cost, the infrastructure, rocketry, maths, physics, politics, risk, or anything else. All of these play into why not all launches are on the equator or close to, but they do generally try and get as close as they can a lot of the time for good reason. But other times they don't for even better reasons. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions that you have below.